What up, man? Been a hot minute since I made a video, but it's time. We got the trigonometry review back from break packet. This video is intended for my students, but just in case you were absent on that first day back, and you need like a full lesson, I'm not going to hop right into these problems. I will at least give a quick little reminder of the main big topic, which is trigonometry, the study of triangles. So the biggest, most important thing when it comes to this lesson are going to be three functions. We're going to call these three functions sine of theta, the cosine of theta, and the tangent of theta. Now, every single time I say this word theta, you can see my drawings are slightly different each time. No matter what, each one of these, this guy right here, you say this word as theta. And this is a variable that is usually used for angles. So we've been using x basically for the previous parts of algebra 1, maybe sometimes y, x, y, z on occasion, but usually those ones maybe have the a, b, and the c, when you're doing the quadratic formula, that kind of stuff. But we use theta for angles in general. You're still allowed to use x, still allowed to use that, but yeah, we're going to use the angles. But each one of these, no matter what, is a specific ratio. That is, it's every single time it's going to be a fraction of some kind, no matter what. So this is one of the things that's bugging people about these is you're guaranteed to have fractions, kind of just the nature of the game. Technically, sometimes they'll cancel out, especially with tangent, actually, where they cancel out to be 1. But every other case is going to be a fraction of some kind. So what are these ratios? We get them from a right triangle. We are going to be extending this idea in a little bit to say a little bit more than a right triangle in just a little while, but we start off with just the triangle to begin with. So this is more of the geometry level version of it before we get to the pre-calculus. So I put my theta over off in the corner, and we typically start by saying that there is an opposite side. To find an opposite side, we kind of just draw a little dotted line going all the way across, and we call this side the opposite, which we'll use a big letter O for. That's not a 0, that's a letter O for opposite. Sometimes we also use the letter A, so we can maybe use a little lowercase a are the oftentimes the letters that we use. Which is a little bit annoying because the other one that's nearby is called the adjacent. And the adjacent here, which sometimes is done with a big capital letter A or a lowercase b, isn't that wonderful, as the choices that maths have chosen. And the word adjacent just means next to. That's a letter A, by the way, if you can't read my handwriting, ADJACENT, adjacent. And it means next to. The longest side, which is always not touching the right angle, the one that's all the way on the other side, we call this one the hypotenuse, which we will be using as the, usually use an H or a letter C for these guys. So sine, cosine, and tangent. Sine is defined to be the opposite over the adjacent. Sorry, I just said that wrong. Opposite over the hypotenuse. Holy moly. The sine is the opposite over the hypotenuse, or if you're using the other letters, little letter A over letter C. The cosine, which, by the way, go back a little bit, the other words there. Co typically means together, so cosine is like the together sign or sine of the other angle. So if I were to draw an angle over there, this opposites would be down here. That's where kind of what the word comes from. So anyways, that's A over H, and or the letters B over C if you're using that. And tangent over here is going to be the opposite over the adjacent, or simply A divided by B. So these are usually the letters that people are going to be using, just as a little bit extra if you needed it. Typically, the entire word is sine, the entire word here is cosine, and the entire word here is tangent. Those are the words that we end up using. Tangent meaning barely touching, and you'll see kind of where that comes from in calculus much later on in your life. So yeah, we have all these things. Anything else I really need to say right away? Oh, don't forget we have the all-important Pythagorean theorem. That is to say, a squared plus b squared equals c squared, or alternatively, o squared plus capital A squared equals the hypotenuse squared. This is going to be pretty dang useful for us later on some of these questions to be doing. That's pretty much the only real algebra we have to deal with. Oh, there's one more thing to help you remember all of these. So we have SOH, CAH, TOA. The most famous one that people like to use is SOHCAHTOA, which is TOA. It's kind of like your way of remembering TOA. It's your way to remembering opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent for all three of these. Anyways, there's my little mini lesson on just like the absolute minimum basics of stuff that you might want to refer to, have as notes, maybe take a cute little screenshot, and then use that to actually solve questions. So here we go for the actual problems. Here we go, trig review back from break packet. Find the value of the trig function indicated. So it says it wants us to find the tangent of theta, SOHCAHTOA. This guy is going to be the opposite over the adjacent. So when you're talking about the opposite over the adjacent, to find the opposites, you kind of just draw a little dotted line going all the way across. So in this case, the opposite is 16, and the adjacent side over there is 12. Super duper useful. And if we, I don't know why I said useful, my brain just skipped to the next thing I was going to say. We have 4 over 3 if we were to reduce that fraction. Technically, you can leave it as 16 over 12 in my class, but future professors or just other teachers might want you to reduce it. So let's circle the reduced answer there. Don't forget, in the event that you're out of practice with this calculator, you are able to use your calculator to reduce those fractions for you. So to use your calculator to reduce the fractions, we'll clear off the calculus you have on there, and then do some fraction stuff, alpha, y equals, enter, and then if you did, why did I do that so fast? I'm trying to teach this. Alpha, y equals, enter. So to find the alpha button, it is this green, sometimes yellow button that activates the F1 keys, and you hit the alpha and then the y equals in the top left hand corner all the way up here. And if you hit those two guys, this little window comes up. You can actually see the other values for F2, F3, F4 that are going to be useful in other things. But n over d is the fraction, and you have the fraction guy, 16 over 12 reduces to that 4 over 3. Anyway, so there's your answer for number 1. For number 2, cosine of theta. So the cosine of theta, using our notes, that's going to be the adjacent over the hypotenuse. So adjacent over hypotenuse is not the opposite, so we really don't need this number 12 at all. We instead need the number 9, and we do need this hypotenuse. So to figure out this hypotenuse, we're actually going to talk about 2 different ways to solve it. There's like the slower way, the standard Pythagorean theorem, and there's also a faster way to do it, which we're going to be adding to our notes a tiny bit when we do that. But to figure this guy out, because we don't have the hypotenuse, we can use our Pythagorean theorem, which says that a squared plus b squared equals c squared. Go ahead, use your calculator if you need it to help yourself do 9 squared plus 12 squared. I'll get you 225. And then to find the answer, we'll take the square root of both sides of the equation. So we'll have the square root of 225 is equal to c, and if you calculator it, you'll end up getting 15. So you get the, number 15 is your value there for C. Which means for our final answer, we can go ahead and get that final answer in there. The adjacent is this close guy here, the number 9, divided by the 15. And that will reduce. They both divide by 3, so 3 over 5 is your final answer. Now, I did say there was a faster way of doing this work, and faster way of doing this work actually also gives you a faster way of getting to the reduced answer. The concept is there are certain values that always work no matter what. So for instance, in the event that I had I'm going to do this in a different color now because it's not part of the problem. If I had any triangle that had a 3 here and a 4 here, this side's guaranteed to be 5 because 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25, which is 5 squared. We call this a 3, 4, 5 triangle, and this is what is known as the simplest Pythagorean triple. So this is a Pythagorean triple. So if you're still doing notes, you might want to add that to your notes there. So we have the Pythagorean triple, but all multiples of the Pythagorean triple also work out. And if you have 2 of the sides in a Pythagorean triple, you also have the third due to side angle side or hypotenuse leg, depending for your geometry review of proofs back there. Either way, you have your Pythagorean triple there, 3, 4, 5. The idea is both of these are also, both these problems are a 3, 4, 5 triangle. Specifically, if I took that 12 there, I'm going to do this in purple now. If I took the 12 and divided it by the same number that 16 is divisible by, they're both divisible by, oh my gosh, hold on, this pen feels like it's sticky. That's gross. Anyways, we have this 12 here and 16. They're both divisible by 4. So if I divide that one by 4, I'll get 3. And if I divide this one by 4, I would get 4. So you'd have, hey, I have a 3, 4, 5 triangle. Instead of dividing by 4, we'd multiply by 4 to get to the hypotenuse. If you multiply by 4, you'd get 20. Likewise, on this question, they're both divisible by 3. So hey, divide by 3, and I get 3. Divide by 3, I'll get 4. And then I have, hey, 3, 4, 5 triangle, multiply by 3, and you'll get 15. So, cute little trick you could do for Pythagorean triples in the event that you're studying for that ACT or SAT. The Pythagorean triples that you want to know top of your head. We got the 3, 4, 5. We got the 5, 12, 13. You got the 7, 24, 25. The 8, 15, 17. And the 9, 40, 41. I don't think usually that those bottom two show up nearly as often as the top 3, and honestly the top 2 are really the most common ones, but it's just good things to look for. You know, you got a 10 and a 24, hey, and the last side's got to be 26 because you multiply by 2. Hey, I got a, I don't know, you got a 15 and a 20, you know the other side's a 25. Because you know, they all divide by 5. So just something to think about when you're doing these questions. Could make it a little bit faster, could make it slower. Anyways, moving on to the next idea. Oh, and what I was saying earlier with the reduced one, if I had gone to my cosine, the adjacent over hypotenuse, I could have jumped right to the 3 over 5, and I didn't even really need to find that C hypotenuse. Anyways, continuing on. Find the measure of each angle indicated. Answer exactly, then express estimate in degrees to the nearest tenth. So this is going to be a little bit different. The idea is we're going to have to use the backwards version of the function. What you have to do is you first have to decide, which one do I have? Do I have sine, cosine, or tangent? So the first step in these questions you're asking yourself, like kind of like a step 1, is sine, question mark, cosine, question mark, tangent, question mark. Which one do I have? So you just simply take your angle and you say, hey, what do I have? Well, I don't have the opposite. Opposite's all the way over here, so it's like the opposites. So because I don't have the opposite side, I want to use the one that doesn't have the opposite side. So let's go to SOHCAHTOA. SOHCAHTOA. Which one of these has the adjacent side and the hypotenuse? Well, in this case, we definitely have the tangent, and I don't know why I didn't switch back to my black pen. So we have this cosine. Specifically, we could say that the cosine of theta is equal to 7 divided by 16, that adjacent side, over the hypotenuse, and we have created a true equation. However, to get theta alone, we are no longer able to do our regular inverse operations that we've been used to because, you know, we have a cosine function. We've never dealt with a cosine backwards before. To do this, what we're going to figure out is we're going to do the cosine inverse. And it has the worst notation in mathematics. I don't think there is a worst notation or a notation I hate more. Maybe there is one and I'm just forgetting what it is. But this is how you write this. So this one right here, the way that you... I'm going to write this now back in purple for a different color. But this one right here is read cosine inverse. And I would remind yourself that this is not an exponent. So it's not an exponent. Because it's not an exponent, it looks like an exponent. It's actually just a superscript, and it means inverse. And we can blame old white guys from the, I don't know, 14 or 1500s that first made these things, and then people have been using them for hundreds of years, and it's impossible to change how everyone on the entire planet writes their math problems. So we can't change the notation. How much better would it have been to just write cosine with a letter I, you know, above it for inverse? So that would have been wonderful. Or maybe a V for inverse. I don't know. Literally anything that's not this. Technically, there is another way you could say it. Arc cosine. That's a very common one in the higher level textbooks. But true mathematicians are lazy as possible and don't want to write arc because that's 3 letters and -1 is only a single thing. Maybe you could say 2 strokes of a pen. So anyways, we say that cosine inverse. This is, when I say answer exactly, this right here is the exact answer and you're done. So that is the exact answer. An angle, done. It's the cosine inverse of 7 over 16. You have nothing else to do. But it does say to express the estimate in degrees to the nearest tenth, and we're using degrees on this question because it is the one that people are most used to. We'll switch over to radians later in the lesson. Let's do this though. So we have the cosine inverse of 7 over 16. To do that on your calculator, step 1, to make sure that you are in degree mode. If you have a nice fancy calculator, you can actually see at the top which mode you're in. I'm in radian mode right now, which means I'm in the wrong mode. Hit the mode button, and you got to make sure you're in degree. We'll be switching between degree and radian throughout this entire time doing trig. Not on this video too much, but on future trig videos for sure. So you just scroll over to degree, highlight it, make sure it's ready to go. My calculator switched up there. Yours might not do that. But there it is. And now we are in degree mode, and we got to use cosine inverse. Cosine is right there. That'll give you some values, but you want that little -1, that cosine inverse. So you hit second, cosine inverse, and the cosine inverse of 7 divided by 16, and it turns out that we have 64.05, 64.1 if you're rounding on the calculator. So we would also say is equal to 64.1 degrees. Holy moly, we're easy peasy. So in the end, that question was actually really fast. You just go calculator, boom, 7 over 16, done. But yeah. Here, so number 4, we are now doing questions that are basically the same thing as before, where you're finding other sides, other angles, that kind of stuff. But now we're doing it a little bit backwards. Yet again, you need to figure out, hey, again, are you in sine, cosine, or tangent? So I'm just going to write down that SOHCAHTOA one more time. So SOHCAHTOA one more time. After we have that SOHCAHTOA, we ask ourselves, hey, which ones do we have here? Well, if we go across from our 67, we definitely have an opposite. So because we have an opposite, it's not going to be cosine, and then the other side that we have over here is the hypotenuse. So because we have a hypotenuse, we have an opposite and a hypotenuse. That one's going to be sine. So we would write that the sine of 67 degrees is equal to the opposite 14.8 divided by the value x. And then you just have to solve this equation. This equation actually has a nice cute little trick to remind yourself is anytime you have any fraction whatsoever that is of the form a equals b over c. By the way, I should have been writing this another color because it is. You're allowed to simply switch these two letters, and if you switch those two letters, you will get c is equal to b over a. You're always allowed to do this for any time math problem that is set up in this fashion. Makes it nice and easy to solve. Don't forget, you can also just bring the c up if you need to. That is to say, I could have also written ac is equal to b, or a, oops, can't even see that. A times c is equal to b. So there is your other option for the situation. But here we're just going to switch these two. So when I'm talking about it, I'm saying, hey, switch these two guys here. And switching those two, you get x is equal to 14.8 divided by the sine of 67 degrees. Like before, when it says answer exactly, this is the exact answer. So this is one of our two answers that we want. For the other one, we just need to practice typing into the calculator. Yet again, our alpha y equals enter comes into great help. Alpha y equals enter, and we got that fraction at 14.8, and then we got the sine of 67, and a beautiful 16.07 or 16.1. Nice. All right, continuing on, same exact idea here. We got to figure out, hey, which one are we in? Are we in sine, cosine, or tangent? If we draw across, we have an opposite. We don't have a hypotenuse. We instead have the adjacents. So in this case, we have cosine because we have the opposites as well as the adjacents as our two sides. Or not cosine. Why did I say cosine? I'm so silly. It's the tangent, opposite over adjacent. I have t written right there. This is not good times. We have the tangent of 20 degrees is equal to 6.3 over x. And yet again, we're in that same situation we were in the previous question, where you can just do a quick little switcheroo of switching things around, and therefore x is equal to 6.3 divided by the tangent of 20 degrees there. So again, we have a oh my gosh, you can't even see my little degree symbol. Whatever, 6.3 over 20, you can see it right there. This is our exact answer, and if we were to type that into our calculator, we would get alpha y equal, alpha y equal enter, 6.3 divided by the tangent of 20, and that's going to give you a 17.3 as a rounded to the nearest tenth. Let's move on to the next page. Here we go. Number 6. So Question number 6, solve each triangle, answer exactly, then express the estimate to the nearest tenth. So when it says solve each triangle, what this means is find all sides and all angles. Find all sides and angles. So the ones that you already have written, you don't actually need. You don't need to find any other ones. We already have the side AC, so we don't need that one. But we do need to figure out what a couple of these are. So I'm going to go ahead and label this one the lowercase letter a. By the way, the reason why we're labeling that side as a lowercase letter a is because it is the opposite of the angle of this one here. We already have this b is equal to 2. Again, opposite that letter B and opposite this side, we have that C over here. So we don't know what A is. We don't know what C is. We'll have to figure out what those are. We already have the angle C as 90 degrees. We already have the angle B as 49.2. We don't know capital letter A. So we need to figure out 3 values here. For these 2 questions, the other angle is extraordinarily simple. It goes back to geometry. You have a right angle. Stuff adds up to 180 degrees. So our letter A is guaranteed to be 90 minus 49.2. And that's going to give you 40.8 degrees. Beautiful. So we have that 40.8 degrees all done there. And now we are looking for that letter A and letter C to get that one. Those 2, we are going to have to figure out our, man, I can't speak today. We're going to have to figure out sine, cosine, or tangent yet again. So let's go ahead and figure out what letter A is first. For letter A, we're going to use this number 2 in some way, shape, or form. We need to figure out that A. Using that, we have a 2 and we have the 49. So we have the opposite of this letter B here. So we have SOHCAHTOA. I'm just going to write this down one more time for you guys. I'm going to draw a little arrow going across over here. So we have the opposite of 49.2, or we have the adjacent of 40.8. It actually doesn't matter which one that you use. Because of the letters I've used on previous pages, I'm going to go ahead and use this 40.8 here, which is going to say the cosine of 40.8 degrees. The cosine of 40.8 degrees, there's this guy, is going to be 2 divided by c. And unfortunately, I'm solving for letter c all of a sudden because I messed up. I don't have a really good explanation as to why I did that. So cosine is equal to 2 over c. So we have c is therefore equal to 2 over the cosine of 40.8. So it does. There's one of the 2 versions of the answer, and we'll go ahead and type it into our calculator for the other one. 2 divided by the cosine of 40.8, and that kind of just shows you, by the way, you don't actually need to use alpha y equals enter, but I like to use it. And this one's going to be 2.64. We only need nearest tenth, so 2.6 for that letter C. There we go. Nice. We have another one of our answers. And continuing on, we have to find that letter A. To find that letter A, again, we can use sine, cosine, or tangent as we feel like it for this last one. I'm going to use tangent arbitrarily because I haven't done a question with tangent yet, or at least not this version of it. The tangent of this letter A here, which is 40.8 degrees, is going to be A over, and that letter B is 2. So we're going to use A over 2. This is one from that previous page. We're just going to want to throw that 2 up there. 2 times the tangent of 40.8, and that was the reason why I chose to use tangent there, so I could actually show that times 2 on it. And this is our exact answer. And for our approximate answer there, we are going to say 2 tangent of 40.8. And by the way, if you thought I was a little bit meandering on this question, I absolutely was, and a little bit of just lost in my own words for a second. But please note, you could have done this question in a great number of ways. Once you have figured out this other angle, you could have used either angle to solve the problem. You could have used the 49.2 or the 40.8. And furthermore, you could have also done some, I don't know, you could have done some other things to figure out sine, cosine, or tangent. So you didn't have to use cosine and tangent here. You kind of could have actually used sine once and cosine once. Yeah, there are other ways to do this question, is what I'm trying to say. So if you had a different method of doing it and you got to the same numbers, you're probably exactly correct. Let's continue on to number 7 exactly the same way. Because it's the same exact problem, or same exact problem type, I'm going to do this one a little bit more quickly. So we are missing, let's go ahead and label these guys. We are missing this lowercase letter a. We are missing lowercase letter c. It just so happens to be exactly the same as the last one. And we are also missing this angle here for this capital letter B. So the capital letter B for the angle, we have that 90 minus 64, and that's going to go ahead and give you 26 degrees. So that one was nice and quick. For the letter A, so we're going to have to figure out this letter A here. By the way, if you did sine of letter A, you can't use 64. Like sine of 64 would equal A over C, and you don't have A or C, you have B. So let's go ahead and you can either use this angle or the 64. I'm going to use cosine again, and you can even use cosine to solve that. I'm going to go for letter C again. What is wrong with my brain today? I don't know. But the cosine of 64 is going to be the adjacent over the hypotenuse, which is 6 over the letter C. And therefore you have C is equal to 6 over the cosine of 64 degrees. Yet again, this is our exact answer. We're done with that part of the question. But just to write down what that decimal is, throw it into the calculator. We got 6 divided by the cosine of 64. And you're going to end up getting 13.69, which is 13.7 if you round to the nearest tenth like the instructions tell you to do. And then after that, we had to solve yet another question. We have to figure out that letter A over here. To figure out that letter A, I am arbitrarily going to use tangent yet again. I don't know why I chose exactly the same things as last time. Maybe I should have picked different ones for different problems, but too late now. And that's going to be A over 6. And we got 6 times the tangent of 64 is equal to that letter A. Circle it. That's the exact answer. And then the approximate answer is 6 times the tangent of 64 degrees, and that's going to give you 12.3 as your other sides there. Let's move on to number 8. So this time you have to draw it yourself. And then it just wants you to find the value of the trigonometry function indicated, which is actually really, really quick. And in some sense, if you are willing to use the previous page's work, you might be able to do these in your head. However, I always recommend drawing a picture as a good habit to get into, especially for those future harder questions. You're eventually going to have to do these things called inverse trigonometric substitutions when you get to calculus 2, and you'll have to practice drawing the triangles, so you might as well just practice them now. It's good for you. So there you go. You draw that triangle down, and it's an arbitrary triangle, and I'm going to go ahead and put a letter A over here in the corner for that angle theta, and therefore that this is our letter A, then this is our letter B, and this is our letter C, and we are told that this guy is 17, and this guy is 15. And if you notice from the previous page, hey, I see a 15 and a 17, we know for sure right away that B is 8. Now, for this answer, it wants a sine of A. Sine of A is the opposite over the hypotenuse. Use that SOHCAHTOA. The sine of A is going to be 15 over 17. So look at that. We hadn't had any work on this question. If you kind of knew and remembered from the previous page, hey, it's, A over C. I remember seeing this A over C right here. I could have said, oh, A is 15, C is 17. We done right away. Kind of a cute thing, but it could have tricked you, because if it said sine of B, well, the sine of B is the sine of the other angle, so it would be 8 over 17. You have to be a little bit careful. Anyways, continuing on, if you are, again, paying attention from that previous page, this is a 724, and therefore that last side is going to be C is equal to 25. You kind of already know that doing this question from the Pythagorean triple. You could have also used the Pythagorean theorem. That's okay, too. But if I were to put this letter A here, we got a 24. We have a 7, and we have a 25 there. Again, you could have used Pythagorean theorem. It's A squared plus A squared plus B squared equals C squared and solve. But we didn't do that this time. The tangent of this letter A is going to be SOHCAHTOA, the opposite over adjacent, which is 24 over 7. All done. Now, this one, again, you gotta draw the triangle right away. This one, you don't really have a choice at all. And this one, you're gonna have to use Pythagorean theorem, because it's got this square root of 19 out of nowhere on it. So it says the tangent of theta is equal to square root of 19 over 9. So let's draw a triangle, put a theta in there, and we need to make it so that the tangent is square root of 19 over 9. Remember that tangent is the opposite over the adjacent from your SOHCAHTOA. So the opposite of theta is going to be the square root of 19, and then the adjacent side over here is going to be 9. So we don't know what this letter C is for this hypotenuse, but we are able to figure it out by doing a squared plus b squared equals c squared. 9 squared plus the square root of 19 squared is equal to c squared. So we got 81 plus 19 is equal to c squared. By the way, don't forget square roots will cancel out as needed there. So square root of 19 squared is just that 19. 81 and 19 together is 100 is equal to c squared. And c is therefore equal to 10. After that, this is going to be the last problem of this video. I'm going to split this into two. I'm going to do questions 1 to 10 and then 1 to 11 because we already hit 30 minutes and I think that's pretty much enough for one night of work. Sine of theta is if cosine is 4 over 5, so you might remember the 3, 4, 5 triangles. You might be able to just jump right to the answer. If you are capable of jumping right to 3 over 5 as your answer, looking at the 4, the 5, opposite adjacent. I remember the 3, 4, 5 triangle. I can do this off the top of my head. I actually encourage that because it means that you're really truly understanding, remembering, mastering the material. So if you're comfortable just going, you know what, I got it, I can do that off the top of my head, then do it. If not, no big deal. Draw the triangle. Put the theta in there. Remember that cosine. This is the adjacent over the hypotenuse. Because of the adjacent over hypotenuse, this guy is a 4, this guy is a 5. We don't know what this side is, but it's a 3, 4, 5 triangle, so we can guarantee that it's a 3. Or again, you could have used Pythagorean theorem. Just in case somebody needs that Pythagorean theorem, I'm going to go ahead and show how you do that. That's letter B that we didn't know. So we knew that it was, or letter A, sorry. We knew that it was a squared plus b squared equals c squared. And if you did that, we got a squared plus 16 is equal to 25. You'd subtract 16 on both sides, get a squared is equal to 9. Take the square root of both sides. And when you do that, you got a is equal to 3. For your final one, that's where we got that 3. Or you could have just done the 3, 4, 5 triangle. Last but not least, sine is the opposite over the hypotenuse. So we are looking for 3 over 5 for that opposite side. 3 over 5 for the final answer. Oh, I never even finished this question over here. What am I doing? I got ahead of myself. I looked at the time and then I'm like, what am I doing? Anyways, the cosine, we never wrote that letter C. The cosine of theta, which we did not do yet. Yikes, Mr. Richards. The cosine of theta is going to be the adjacent of hypotenuse, which is 9 over 10. Okay, we actually finished these two. We'll resume this video from question number 12 a little bit later. Maybe I'll make that video tomorrow. Peace out, guys.